Yeah, welcome back. So now we are going to study some mathematics, right? First we will see the conditional probability and then we will see integral calculus. So even if you have studied these topics in your mathematics, still I would say don't ignore it completely. You can watch it in a quick manner, within 10 to 15 minutes you can watch it completely, but don't ignore it completely, okay? Just quickly go through it. So what do you mean by conditional probability? So conditional probability is given by probability of event A given that event B has already occurred. Probability of event A given that event B has already occurred. Let's understand by an example. So this is your random experiment. You are doing an experiment, that is you are rolling a dice. Now what is the probability that the given number is even given that it is greater than 2? So which event has already been occurred? That you have got a number greater than 2. So event B has already occurred such that the number is greater than 2. That means the number could be 3, 4, 5, 6. Right? What was your actual sample space? Like what was your actual experiment? This was your random experiment. When you roll a dice, what all outcomes you can get? 1, 2, 3, 4, 5, 6. These outcomes you can get. Now you are asked the probability of getting a number that is even. So even number could be 2, 4 and 6. Right? So what could be your even number? What would be your event A? That would be 2, 4, 6. But you don't need to find the probability of A. No. This is not they are asking. They are asking the probability of A such that B has already occurred. That means you already know that the number is greater than 2. You already know that when you roll the dice, you already know that the number coming would be either 3 or 4 or 5 or 6. Now what is the probability that number would be even? So you are having 2 chances out of 4. So what would be the answer? 1 by 2. There you go. So answer would be 1 by 2. What is given? The number is already greater than 2. So what you can get? 3, 4, 5 or 6. Out of these 4, any number you can get. Now they are asking what is the probability that it should be even. So that would be 2 divided by 4. That would be 1 by 2. So this is the concept, that this is how 1 by 2 is calculated. What is the formula? Let's see the formula as well. So formula says probability of A by B. That means probability of event A given that event B has already occurred. That would be A intersection B divided by B. Okay. So this downward, this remains downward only, and on the upper side intersection of both of them will come. What do you mean by intersection? So I said one thing, whenever I say OR, that means addition and that means union. Okay. What is union? This is the sign of union. I hope in the set theory you have studied these basics. And whenever I say AND means multiplication, or you can show it by dot. And intersection. What is this intersection? Intersection is this sign. That means probability of event A and B. Probability of event A and B. Probability such that you are getting a number that is even and greater than 2. Even and greater than 2. So when you roll a dice, what is the probability that you get a number which is even and greater than 2? So what is the probability that it should be even? 2, 4, 6 and greater than 2 as well. That means this will not come. So 2 cases out of 6. 2 cases out of 6 divided by probability of event B. What is the event B? The number should be greater than 2. So when you roll a dice, number is greater than 2. 3, 4, 5, 6. So out of 6, there are 4. So by the formula as well, you are getting 1 by 2. Are you able to understand this point? So this is the meaning of conditional probability, which a lot of guys already be knowing, right? Very simple concept. One event has already occurred. Now what is the probability of event A such that event B has already occurred? Well and good. So from here, this part is important, that this particular formula is important for you, right? Whatever the formula that you are getting, this particular formula is important. From this formula, can you let me know what will be A intersection B? What will be the probability A intersection B? That would be, this B goes here. So what you will be getting? PA by B dot PB, right? Basically, what was your PA by B? Your PA by B was PA intersection B divided by PB. So this PB goes here, you will get PA intersection B. Now, if A and B are independent events, what is the meaning of independent events? That means event A does not depend on event B and event B does not depend on event A. You see this question, you are rolling two dice simultaneously, right? So first die will show an even number and second die will show a 3. Basically, event A is that such that first die will show a even number and event B is that the second dice is showing 3. So getting a 3 on the second dice, will it be anyhow related to getting even on the first dice? No. Are you able to understand what I am saying? Getting a number 3 on second dice, whatever the number that you get on second dice, is that anyhow related to get a number on the first dice? No. First dice and second dice, they are not related with each other at all. That means they are two independent events. So here if I ask you, what is the probability of A? What will be the probability of A? First die shows an even number. So even number, that would be 3 by 6. Now let me know what will be the probability of B. Second die shows a 3, 1 by 6, right? If I ask you what is the probability of A by B, that means probability such that probability of getting an event A, probability of event A such that event B has already occurred. So on the second dice 3 has come. On the second dice 3 has come. Event B has already occurred. On the second dice 3 has come. Now what is the probability that on the first dice even number would come? Does that depend on B? No, right? On the second dice, if you are getting a 3, you are getting it, right? You are getting a 3. On the first dice, the number would be even, odd, it would be 1, 2, 3. Does it depend on the second dice? No, it doesn't depend on the second dice. So that would be equals to P of A only. And that would be equals to 1 by 2. And what would be P B by A? What would be your P B by A? That would also be equals to PB only. Because let's just say on the first dice even number is coming. On the first die even number is coming. So does that getting a 3 depends on this? Like whatever the number you are getting on the second dice, does that depend on the first dice? No. So that would also be equals to 1 by 6 only. And here one more thing you can see, P of B by A would be equals to PB intersection A divided by PA. So B intersection A is equals to A intersection B only. So from here you can get B by A dot PA as well. So both of these formulas are true. Okay. So this also should be there in your mind. And if A and B are independent, that means this would be equals to probability of A only. That means it will not depend on B. So what this is actually equals to? It is actually equals to this particular thing, right? Basically, first this is the condition. First this is the condition. Okay. First this is the condition. Now secondly, you know that your PA by B is actually equals to PA intersection B, or from here you can see what you can see, PA intersection B is equals to PA by B dot PB. Now since A and B are independent, so this PA by B would be equals to PA only. So if A and B are independent, then simply this intersection will be converted to multiplication. Intersection will be converted to multiplication if A and B are independent. If they are independent, then this would be the case. Okay. In a lot of cases, in 80% of the cases, you will get independent events only. We will see it in communication. So if they are independent, that means PA intersection would be equals to PA dot PB. So this should be there in your mind, and this should also be there in your mind. Okay. Let's see a theorem. The name of the theorem is not important. So what is the condition here? Here there are 4 events: event E1, event E2, event E3, and event E4. in those 4 events, one event A is common. That means A is occurring with E1 as well, A is occurring with E2 as well, A is occurring with E3 as well, and A is occurring with E4 as well. So can you write down the probability of event A? Yes sir. The probability of event A would be equals to E1 intersection A, E1 intersection A. Basically this area I have taken into consideration. E1 intersection A plus probability of E2 intersection A plus probability of E3 intersection A plus probability of E4 intersection A. So this could be equals to probability of E1 dot A divided by E1. You see here A by B dot B. So A by E dot A by E1 dot E1. This could be equals to probability of E2 A by E2. Is that clear to you? In digital communication as well, this will be used. Okay, probability of A. Everywhere it will be used. A by E1 dot E1. A by E2 dot E2. You are finding the probability of A. So how will you read it? Probability of event E1 multiplied with probability of event A such that E1 has already occurred plus probability of event E2 multiplied with probability of event A such that E2 has already occurred plus probability of event E3 multiplied with probability of event A such that E3 has already occurred. Or plus can be written as or, plus can be said as or probability of event E4 multiply with probability of event A such that E4 has already occurred. So let me read this statement again. Probability of event A would be equals to probability of event E1 and probability of event A such that E1 has already occurred, or probability of event E2 and probability of event A such that E2 has already occurred, or probability of event E3 and probability of event A such that E3 has already occurred, or probability of event E4 and probability of event A such that E4 has already occurred. So this would be the probability of A. This should be there in your mind. You should not be mugging it up. Everything is crystal clear to you. Every single thing is crystal clear to you. It will be more clear when we see the example. So these conditions are given that 1% of the people are having a disease. A particular disease is there, only 1% of the people are having it. That means 99% of the people are not having this disease. 99% of the people are not having this disease, right? So 0.01 here 0.99. Now test is 99% accurate. What is the meaning of this? You conduct a test which is 99% accurate. What is the meaning of this? So the scenario is like either you will be having a disease or you will not be having the disease. Either you will be having the disease or you will not be having the disease. But even if you are not having the disease, still the test can say positive. Are you able to understand this point? What I am saying? Even if you are not having the disease, still the test can say positive. If you are having the disease, test is saying positive. If you are not having the disease, still the test is showing positive. So this is the Venn diagram of saying positive. This is the Venn diagram of disease. This is the Venn diagram of non-disease. Disease is 0.01. This is 0.99. You don't know what is the probability of giving positive result. You don't know that. But you know that even if you are having the disease, still it can give you positive. Even if you are not having the disease, still it can give you positive. What they are asking? What is the probability that person actually has the disease? What is the probability that person is actually having the disease given that their test is positive? Their test is positive. Their test is positive. So test is positive given that test is positive, but this guy is having the disease. What this would be equals to? Divided by probability of having positive, right? You can get this very easily. How will you get this particular thing very easily? Because what they have given, probability of positive divided by the disease, that is equals to probability of positive intersection with disease divided by disease, that is equals to 0.99. So what you are getting from here, disease intersection positive, that is coming out to be 0.99 into probability of disease is 0.01. So the job of this particular thing is done, 0.99 into 0.01. But now what you need to find, probability of positive. So probability is such that this particular test will give you positive result. Probability such that the test is giving you positive result. So what you can see here, disease intersection with positive plus no disease intersection with positive. That means the guy is having the disease. The guy is having the disease, and after having the disease, it is giving you positive result. This could be the case. Or the guy is not having the disease, and even after not having the disease, it is giving you positive result. Two cases would be there. Is that clear to you? The guy is having the disease. Even after having the disease, it is giving you positive result. Or the guy is not having the disease, and even after not having the disease, it is giving you positive results. So this will be the probability of getting the positive results. So what is the probability of having the disease? That is 0.01. What is the probability of giving the positive result even after giving the positive results, given that the guy is having the disease? So positive divided by disease is 0.99 plus what is the probability of not having the disease? That is 0.99 into failing here is 0.01. So this is actually coming out to be 2 into 0.01 into 0.99, right? So what is the answer you are getting? Probability of having the disease given that the test is positive. So 0.99 into 0.01 divided by 2 into 0.01 into 0.99. So what is the answer? 1 by 2. That means if you are in this hospital, even if your result is coming positive, still there is only 50% chances that you are actually having the disease. 50% chances are there that you are actually having the disease, 50% chances are there that you might not be having the disease. Is that clear to you? The result has come positive. Now 50% chances are there that you might be having the disease, 50% chances are there that you might not be having the disease. Is that clear to you? So answer would be 0.5. So this is the answer. Okay. So just don't focus much on that, because in mathematics you will again study it. Just because this will be used in our analysis somewhere in digital communication and even in random variable as well. That's why I put this particular topic here. Okay. Let's solve the questions now. CDF of random variable y is given. Fy of y. You need to find the probability of y less than 2 such that it is given that y is greater than -1. Okay. So let's find the probability. Probability of y less than 2 given that y is greater than -1. So it could be written as y less than 2 and y greater than -1 divided by probability of y greater than -1. Okay. What this could be written as? That y is greater than -1 and less than 2. So can I write it down in this manner? Divided by probability of y greater than -1. Now let me know what will be the answer of this one. Fy of, here you needed the sign, right? Here you needed the sign. So here you will put 2 minus Fy of, here you do not need the sign. So -1. Here I need to make the changes. What change I can make? 1 minus probability of y less than equals to minus 1. Do you agree to this point? You need y greater than minus 1. That means 1 minus less than minus 1 including the minus 1 as well. So what you are actually getting? So here you can see that y greater than 2, sorry, y less than 2 divided by y greater than minus 1 is actually coming out to be fy of, here I can put in place of 2 minus I can only put 2. Why is that so? In place of 2 minus I can only put 2. Why is that so? Because this is continuous, no? You can see fy of y is continuous. This is a continuous graph. There is no staircase or anything like that. This is a continuous graph. So in place of 2 minus I can only put 2 only, divided by fy of minus 1 divided by 1 minus fy of minus 1, right? All good. What is this? Fy of minus 1. I am only interested in this particular value. You let me know what will be the value of fy of minus 1. So here in this particular graph, if I put fy of minus 1, what that would come out to be? 1 minus e to the power 1 u of minus 1. What is the value of u of minus 1? 0. Usually what people will do is that they will only look at this particular thing. But you need to see that this particular graph is starting from y greater than 0. If you draw the CDF, how will you draw the CDF? If you draw fy of y versus y, so random variable y is taking values greater than 0 only, right? Because what you will get at 0, this will be 0. What you will get at infinity, that would be 1. So it is rising from 0 to 1. So this kind of graph you will be getting. This is your fy of y. So here also directly you can see the probability that random variable y taking value greater than minus 1. It is 100%, no? Probability that this particular thing taking value greater than minus 1, that is 100%. Why 100%? Because you know that y is taking values from 0 to infinity only. Y is not taking these values. Y is taking values from 0 to infinity only. Or you can see here, fy of minus 1 is coming. What is the value of u of minus 1? That is 0. So fy of minus 1 is coming out to be 0 only. So this particular thing is 0. And divided by 1 minus 0 would be 1 only. What is the value of fy of 2? So fy of 2. So 1 minus e to the power minus 2 into u of 2. What is the value of u of 2? That is 1 only. So what you are getting? 1 minus e to the power minus 2. So here fy of 2 is coming out to be 1 minus e to the power minus 2. Fy of minus 1 is coming out to be 0. 1 minus 0. So what is the answer you are getting? 1 minus e to the power minus 2. This is the answer we are getting. 1 minus e to the power minus 2. Okay. So here in place of y, we can put 2. Y of 2 is 1. So 1 minus e to the power minus 2. 1 minus e to the power minus 2. Fy of minus 1. Fy of minus 1 was 0. Fy of minus 1 was 0. 1 minus fy of minus 1. Fy of minus 1 was 0. Or here only you could have said that it would be 1 only. Probability such that your random variable y is taking value greater than minus 1. Greater than minus 1. Always it will take value greater than minus 1 only. So this would be 1 only. There you go. Well and good. Okay, so this was CDF given and this question we solved. Let's try solving this question. There is a sample space S which is defined like this. That means what is your sample space? This sample space is S1, S2, S3, S4. Okay. Probability of S1 is given, probability of S2 is given, S3 is given, S4 is given, right? Now there is a random variable x of Si is defined such that it is I minus 2, value of I will go from 1 to 4 only. So what do you understand by this? That your random variable x will take values I minus 2. That means if I put I equals to 1, what will be the value? Minus 1. If I put I equals to 2, what will be the value? 0. If I put I equals to 3, the value will be 1. If I put I equals to 4, the value will be 2. So random variable can take minus 1, 0, 1 and 2 value, right? Your random variable can take these values. Now what you need to find? You need to find PMF. That means what is the probability such that your random variable x is taking value -1? So when it will take value -1? When I is equals to 1. Basically x belongs to -1 when I is equals to 1. That means this would be equals to probability I is equals to 1, probability of S1. Are you able to understand this point? This -1 is associated with S1. This is associated with S2, S3, S4. So basically what really happened was that you are having this sample space, and in this sample space there are 4 points S1, S2, S3, S4. These 4 sample points are there. So S1 have been mapped to S1, this sample point. Since this particular sample point is having I equals to 1, that means this have been mapped to 1 minus 2, that is -1. This have been mapped to 0, 2 minus 2 will be 0. This have been mapped to 3 minus 2, 1, and this have been mapped to 4 minus 2, 2. So these are the values of small x, you can say, right? So probability of x equals to -1 will be equals to 1 by 6. Probability of x equals to 0 would be equals to 1 by 3. Probability of x equals to 1 will be equals to 1 by 3, and probability of x equals to 2 will be equals to 2 will be equals to probability of S4, that would be equals to 1 by 6. Okay, so what you are getting here, random variable x is taking values -1, 0, 1 and 2, right? At -1 you are having 1 by 6, 1 by 3, 1 by 6, 1 by 3, 1 by 3 and 1 by 6, right? 1 by 6, 1 by 3, 1 by 6, 1 by 3. So this is the PMF. Okay, Px of x versus x. This is the graph. -1, 0, 1, 2. So 1 by 6, 1 by 3, 1 by 3, 1 by 6. All good. So this is the answer. Okay. So yeah, that's about the conditional probability and these questions we have seen. Now we are going to move towards two-dimensional random variable. Also we will see integral calculus. So first we will see some questions on integral calculus. I am not going to give you the complete concept. Some questions we are going to see, and then we will move to our two-dimensional random variable. So till now we were defining only one random variable. Now we will define two random variables, right? So this is a very important concept, and usually it is confusing for a lot of students. So I will pause the video, I will change the slide, and then I will come back and we will study about integral calculus. Okay, yeah, thank you. Yeah, welcome back. So continuing our mathematical part only. So now the thing is we need to study integral calculus. But now I am not going to give you the concept of integral calculus. This you should be already knowing from engineering mathematics. If you haven't studied engineering mathematics, then from EMFT you can cover this particular concept. So you can go to YouTube and type integral calculus PrepFusion EMFT. So you will get this video. In this video, there is very high chances that most of the concept will be cleared. Like whatever that is useful in communication system, that particular concept will be clear to you. Is that okay for you? Because now we need to study two-dimensional random variable. So till this point what we were doing, fx of x dot dx. Now there will be two random variables. So here what was happening, random variable x was taking values from, let's just say, from 0 to 3. But now random variable x will also take the value, random variable y will also take the value. So x will take some value, y will take some value. So now integral calculus will be used, double integral will be used. Single integration we already know, right? This was taking the limit of x. Now this will take the limit of y as well. So before that, this is the prerequisite that you should be comfortable with the integral calculus. Now in this particular video, what we are going to do is that we are going to solve some problem on integral calculus. some questions we are going to see, because those who have already studied it, they can revise it through the question. So basically those who already know this concept, for them it will be a kind of revision. Okay, so this integral calculus will be a kind of revision. Through the question you can revise it. So questions I have taken in a manner that will be used in our analysis. Is that okay for you? Understood? So if you haven't studied, then watch this video. If you have already studied, then you will be able to revise with these kind of questions. So what is the first question? That you need to draw the region R. X is greater than equals to 0, y is greater than equals to 0, x plus y is less than equals to 2. These kind of questions we have seen in our elementary classes. In class 11, 12th we have seen how to make the region R. So this is the first question, that you need to draw the region R. So let's draw the region R. So two axes are there, x and y, x and y. So x is greater than 0, that means all this region will come. Sorry, x is greater than 0, x is greater than 0. So this particular region will come, right? Now what they are saying, y is also greater than 0, y greater than 0, that means which region would come? This region would come, y is greater than 0. So in both of them, what is the common region? This is the common region, no? That x is greater than 0 here, y is also greater than 0. So one thing we got to know, that we are talking about this particular region now, that x is greater than 0 and y is greater than 0. So we are talking about this particular region. Now second, what they have given, x plus y less than equals to 2. So the another inequality is x plus y should be less than or equals to 2. So how to make these kind of, how to solve these kind of problems? What you will do is that you will first make this line. Forget about the inequality. First you make this line, x plus y equals to 2. So how this line will look like? This is how the line will look like. Slope is negative, right? Y equals to, let's make the diagram a bit bigger. What I can do is that I can make this diagram a bit bigger. This was your y axis, this is your x axis. X greater than 0, y greater than 0, these two conditions. Next condition is x plus y less than equals to 2. So first I am going to draw this line. This is the line of x plus y equals to 2. You can see that y equals to mx plus c. So slope is -1 and it will cut on 2 here. Or what you can do is that if you put x equals to 0, what will be y? If you put x equals to 0, y will be 2. If you put y equals to 0, x will be 2. Right? X plus y greater than equals to 2. This line we have drawn, which is x plus y equals to 2. But x plus y less than equals to 2, this is what we need. That means either this region will be there or this particular region will be there. So which particular region will be there? How will you check? You take any random point in this particular region. Let's just say I take point 0, 0. I will put 0, 0 here. 0 plus 0 is less than 2. 0 is less than 2. Yes, it is true. That means 0, 0 will be included. That means this particular region will be your answer. This particular region will be your answer. Are you able to understand this concept? X greater than 0, x greater than 0, y greater than 0, x plus y less than equals to 2. So I draw the line of x plus y equals to 2. Right? Now less than equals to 2 or greater than equals to 2. How would I know which is less than equals to 2? So I will take a random point. This is a random point that I have taken, and I put this random point in this equation. 0, 0, 0 is less than equals to 2. Yes, this particular equation is true. That means this would be my region. So what did you understand? X greater than equals to 0, y greater than equals to 0, and x plus y less than equals to 2. So x greater than equals to 0, y greater than equals to 0, and x plus y less than equals to 2. So that means our region of operation, our matter of concern is this particular region. Do you agree to this point? Our matter of concern is this particular region. This is our matter of concern. X greater than 0, y greater than 0, x plus y less than equals to 2. Say yes or no. Now what do you need to find? So this region I have drawn. Okay, better I should show by dots only. So this is the particular region that I have drawn. This is our matter of concern. what I need to find? First one, region R dx dy. What is the meaning of this dx dy? That in this particular region you need to find dx dot dy and then double integration. That means simply you need to find area. You need to find the area of this particular region. If dx dot dy and then region R is written, that means you need to find the area of this particular region. What will be the area? 1 by 2 into what is the base? Base is 2. What is the height? Height is also 2. So answer would be 1. There you go. Direct dx dy is written, that means you need to find the area of this particular region. Now second, they are asking xy dx dy and region R they have written. Now this is a particular function that they have given and you need to integrate this particular function with respect to dx dy. So here you have to put the limit. You have to put the limit of x as well. You have to put the limit of y as well. Here also you need to do the same thing. Here also you need to do the same thing. Here also you need to put the limit of x, you need to put the limit of y. But I am telling you one particular thing, that if direct dx dy is written, that means you need to find the area. So area you have done. But now there is a function xy dx dy. So now you need to put the limit. And how do we put the limit? For putting the limit, what do we do is that we take a strip. We can take a vertical strip as well, we can take a horizontal strip as well. Usually we take the vertical strip. So what I will do is that I will take a vertical strip here. So I have taken the vertical strip. Okay. Now on this strip, you let me know how will the limit of y will go. So here what is the value of y? Y equals to 0. And here what is the value of y? Y is equals to 2 minus x. So limit of y is going from 0 to 2 minus x. Limit of y is going from 0 to 2 minus x. How the limit of x will go? So what I will do is that now I will move this strip in x direction. First I have taken the limit of y. Now this strip will be moved in x direction. In x direction this strip will be moved. In x direction this strip will be moved. So value of x will be taken from 0 to 2. If you move this strip in the x direction, the value of x will be taken from 0 to 2. So value of x will go from 0 to 2. Always the constant limit you will put on the second integration, the variable limit you will put on the first integration. So limit of y is going from 0 to 2 minus x, limit of x is going from 0 to 2. 0 to 2 minus x, limit of x is going from 0 to 2. Always from lower limit to higher limit. Is that clear to you? Okay. Now I need to solve the integration. So first I am integrating with respect to y. So what I will do? Limit of x is going from 0 to 2. I am integrating with respect to y. So x will be a constant now. Right? And I can put dx here as well. Now you need to do the integration with respect to y. Y dot dy. So let's keep this part as it is. This part is as it is. I don't care about this part. Y square by 2, 0 to 2 minus x. What you are getting? This part is there as it is. 2 minus x whole square divided by 2, and then you put 0, that would be 0 only. Okay, so let's write down this part now. What this part was there? X is going from 0 to 2, x as it is. Now this integration will give you, what this integration will give you? 2 minus x whole square. 2 minus x whole square divided by 2 dot dx. This particular integration, y square by 2, 0 to 2 minus x. So here in place of y 2 minus x, you put 2 minus x whole square divided by 2 x dot ds. So here x dot dx, and limit of x is going from 0 to 2. Is that clear to you? This 2 minus x could be written as x minus 2 as well, right? Negative sign you can take common, and already there is a square, so this can be written as x minus 2 as well. Just it looks good, that's why I am putting x minus 2, nothing else. It looks good, that's why I put x minus 2, nothing else, right? So what you will get? 1 by 2 can be taken outside. Limit of x will go from 0 to 2. A square plus b square minus 2ab dot dx. 1 by 2 is outside. A square plus b square minus 2ab. So 1 by 2. Limit of x goes from 0 to 2. X cube minus 2x square plus 4x dot dx. So 1 by 2. X to the power 4 divided by 4 minus 2x to the power 3 divided by 3 plus 2x square. 0 to 2. So 1 by 2 here, 4 minus 16 by 3, just I am putting the limit, nothing else, plus 8. So 12 minus 16 by 3 into 1 by 2. 20 by 3 into 1 by 2. So answer is 10 by 3. This is the answer. Well and good. Okay, I hope the calculation is correct. You can check the calculation on your own. Just I wanted to tell you that how we solve the problem. So first we will make the region. Always we will make the region. Three equations were given: x greater than equals to 0, y greater than equals to 0, x plus y less than equals to 2. All the equations were given. I made the region. Now for this particular thing, dx dy, it was very easy. I got the area, right? But here there was a function. This was a function of xy. So now I need to take the strip. How will I take the strip? I will take the strip from, I will take the vertical strip. I can take the horizontal strip as well, but usually we take the vertical strip. In this particular video, you will find a lot of examples where I have taken the horizontal strip as well. Horizontal, vertical, whatever the strip you want to take, that you can take. So I am taking the vertical strip going from y equals to 0 to 2 minus x. So limit of y is going from 0 to 2 minus x, limit of x is going from 0 to 2. So you can see this. This is how we need to solve it. So now always the constant limit I will put in the end, and here I will put the variable limit. So x dot dx, y dot dy, y square by 2, 2 minus x whole square divided by 2, 1 by 2 is coming outside. This is becoming x square plus 4 minus, yeah, there you go, wrong. A square plus b square minus 2ab, right? Minus 2ab. So this would become 4x, no? Right? So x cube minus 4x square, x cube minus 4x square plus 4x dot dx, x to the power 4 divided by 4, 4x to the power 3 divided by 3, yeah, 1 by 2 is outside, 16 divided by 4, this would be, what this would be, 2 to the power 3 will be 8, 32 by 3, 32 by 3, 8. So 12 minus 32 by 3, 4 by 3 into 1 by 2. So that would be 2 by 3. So answer is coming out to be 2 by 3, not 10 by 3. My calculation error is there. So answer is coming out to be 2 by 3. Is that clear to you? All good? All fine? Let's go to the next one. Here x greater than 0, y greater than 0, x plus y less than 2. Till this point we have already made. Now they have given another thing, that is x plus y greater than 1. So you need to draw the region R. So can you draw the region R? Surely I can draw the region R. X plus y less than equals to 2. So till this point I have already made. Now x plus y greater than equals to 1. Again let's draw it on the next page, okay? Because I need to make the bigger diagram, no, so that you understand. So I will make the bigger diagram. X greater than 0, y greater than 0, you already know. That means I will be talking about this particular region. Now two more equations are there. X plus y less than 2. So x plus y equals to 2 I will draw. And then another equation is x plus y greater than 1. So x plus y equals to 1 I will draw. So these two I will draw. X plus y equals to 1 and x plus y equals to 2. Now x plus y less than 2, which was this side, right? Now x plus y greater than 1, what do you think which side it will be there? X plus y greater than equals to 1. So if I put this particular point 0 0, so 0 plus 0 is greater than 1. That means this particular point should not be included. That means it will be towards this side. Are you able to understand this point? X plus y less than 2. One equation was x plus y less than equals to 2. That means this was the region. Now x plus y greater than 1, this will be the region. How will you check? You will take this origin, you put this 0 0 here. So this particular region is not satisfying. 0 is not greater than equals to 1. That means this particular region would be the matter of concern. So what do you think, what is our matter of concern? Final matter of concern. Final matter of concern is this particular region. All this region is our matter of concern, because x should be greater than 0, yes. Y is greater than 0, yes. X plus y should be less than 2, yes, and x plus y should be greater than 1, yes. So this is our matter of concern. This is the matter of concern. All good, all fine. Now what we need to calculate? What was this point? Let's write down the point. 2 0, not 2 0, 0 2. X equals to 0, y equals to 2. X equals to 2, y equals to 0. This point will be 0 1 and this point will be 1 0. First one, you need to find this particular thing. That means simply the area. Area of what? Area of region R, area of this particular thing. This dotted area you need to find. Right? So can you find the area? Yes, what I will do is that I will find the total area minus this area. Right? What I will do, this would be equals to, what is the total area? What is this total area? That would be 1 by 2 into base into height minus 1 by 2 into 1 by 2 into base is 1, height is 1. Basically, I calculated this total area minus this area. This is what I am doing. Very simple for you. 1 by 2 base into height. 1 by 2 into 2 into 2. Here, what is the answer that I wrote? This was actually 2, right? 2 get cancelled. This answer is 2. Yeah. So 1 by 2, 2 into 2. 1 by 2 base into height. Here 1 by 2 base into height. 1 by 2 base into height. So 2 minus 1 by 2. What you are getting? 3 by 2, which is equals to 1.5. So this is the answer you get, 1.5 for the first question. Now for the second one, you need to choose the strip. So let's solve the second one here. xy dx dy. What you need to do? You need to choose the strip now. Let's take the strip. Which strip I will take? Vertical strip I will take. So this vertical strip I am taking. Okay. In this vertical strip, how will my y will go? Here in this vertical strip, here what is the value of y? Y is 1 minus x. And here what is the value of y? Here y is 2 minus x. So y will go from 1 minus x to 2 minus x. Is this correct? Just think about it. First you have chosen the strip, right? Now you will move this strip as well. So if I am moving this strip will go upward, it will come downward as well. So it came down. So always, yeah, till this point, here as well, you are going from 1 minus x to 2 minus x, 1 minus x to 2 minus x, here as well, 1 minus x to 2 minus x. This strip will come like this now. The strip will come down. This is like a, just understand this particular thing. So this will go upward, it will come downward as well. It is coming downward. Now it has come here. Now here what is y? Y equals to 0. And here what is y? 2 minus x. So you need to break it down now. Are you able to understand this point? Did you understand this point? There is something different here. What is different here? That after this point, after this particular point, things are changing. So this particular strip will work when x is going from 0 to 1. What I am saying? This particular strip will work when x is going from 0 to 1. In this strip will keep on moving. So what is the limit of x? X is actually moving from 0 to 1 only, no? Right? If you are moving this strip like this, that means in the x direction you are moving from 0 to 1. So how will you break it? In x direction I am moving from 0 to 1. But in the y I am moving from 1 minus x to 2 minus x. 1 minus x to 2 minus x. xy dx dy. Plus, now here you need to choose different strip. This strip I need to choose. Because here what is actually happening? When your x is going from 1 to 2, when your x is going from 1 to 2, your y is going differently. Your y is going in a different manner. Y is actually going from y equals to 0 to y equals to 2 minus x. Is that clear to you or not? So two kind of strip I need to use. Always I will choose one strip and I will move it. Once I move it, I will get to know that how my y is moving. Here y is moving from 1 minus x to 2 minus x. Here it is moving from 0 to 2 minus x. And how the x is moving? In the x you can see that constant limit 0 to 1 and 1 to 2. So here constant limit x goes from 1 to 2, but y goes from 0 to 2 minus x. Okay, so you can solve this integration on your own now. How will you solve on your own? I will solve. Right, so I will solve it in a quick manner. X dx, now this would be y square by 2, and here I need to put the limit. Okay, this will be a long integration, and then dx, and limit of x goes from 0 to 1. This is going to be a long integration, right? I will tell you a short method as well actually. So that's why I don't think I should solve it more. Right? You guys can do it on your own. What do you think? Right? You guys should be able to do it on your own. And here x is going from 1 to 2. X dot dx I need to do. This dx I can erase. Here I integrated y square by 2 I get 1 minus x to 2 minus x dot dx I need to do. Then here I integrated y. What I will get? Y square by 2 I will get. And then 0 to 2 minus x you will go. Dot dx you need to do. Okay. You solve it, whatever the answer you get, that would be fine. Now let me take this diagram again. Let me take this particular diagram again, and I will tell you one another method. What is that method? Let's see it. Okay guys, it is lagging actually. Let me pause the video, it is lagging. Yeah, so diagram is copied now. Yeah, so let's remove all these things. Let's remove all these things. Look, I said that I got to know that basically I need to calculate this particular thing. What is that? In the region R, I need to calculate xy dx dy, xy dx dy. Right, this is what I need to calculate. And then I got to know that if I choose the strip, everything will become difficult here. I need to break down the strip in two manners, so things will become difficult for me. That I got to know. So what I thought, that I have already solved for this particular region. In the previous question only, I have already solved. In which question? In this particular question. So for the complete region, I have already solved the integration. That is xy dx dy for region R. For this complete region, I am calling as R. Right? So now this particular region, I will call this as R dash now. So this is my R dash now. R dash. R dash. Okay, R dash. So now what I am doing is that I am calling this particular region as R dash, and I am calling this particular region as R double dash. Which particular region? This region. This region I am calling as R double dash. So can I say that this integration xy dot dx dy, which I am calling as R dash. Which region? This region is my R dash. This is my R dash. Would be equals to what? Region R xy dx dy minus region R double dash dx dy. Say yes or no. Basically, you can see that R dash plus R double dash is making the region R. So what you need to find? You need to find R dash. That means you can do R minus R double dash. Although I need to calculate this particular integration, but I will calculate the integration in this region, and then I will subtract from somewhat I already know. I already know the value of this one. What is that? This is 2 by 3. This value is, I already know, that is equals to 2 by 3. Now you will say that, sir, actually in the examination again I will have to solve two integration. This integration I will have to solve, this integration I will have to solve. Yes, this you need to solve, but whatever the concept that we are going to study in our probability in random variable, what will happen is that this will actually become 1, and you would be already knowing it. What I mean to say is that we are going to use this concept in a two-dimensional random variable. That's why we are studying it. So there what will happen, this particular thing will throw 1, and you would already know it. We will see the example, it will be clear to you. So there what will happen is that it will be easy for you to calculate this particular integration. Otherwise you will have to take the limit and you will have to calculate in this manner, which will be large. But what you will do is that you will see that here, if I take the strip in this particular region, if I take the strip, then this strip will go only from y equals to 0 to y equals to 1 minus x. This strip will go from y equals to 0 to y equals to 1 minus x, and in the x it will go from 0 to 1. It will be very easy for me to calculate, and then I can subtract it from this whole integration. Although in the previous question I have already calculated this whole integration, that is coming out to be 2 by 3. But in probability what will happen is that this integration will become 1. How it will become 1, that we will see. But in probability it will become 1. As of now you think that this we have already calculated, so it was 2 by 3. So now our target would be that we calculate xy dx dy taking the limit of x from 0 to 1 and taking the limit of y from 0 to 1 minus x. There you go. So I need to solve this integration only now, which has become much easier than this particular thing, right? So if this kind of thing is coming that you need to change the strip, then you would always do one thing, that instead of calculating in this particular region, I will calculate in this particular region, and I will calculate for this particular region. Then I will subtract both of them, and surely I will get this particular region. Okay, and in probability what will happen is that this whole region, this will throw 1. This integration will throw 1. Your double integration on this whole region will throw 1. And what if in the examination you need to find this particular region? So you would know that 1 minus this region. That would be your answer. Is that clear to you? Okay. So just another method I am telling. Now you need to solve this integration, which is easy for you. So 2 by 3, limit of x is going from 0 to 1, x is constant, y square by 2, 0 to 1 minus x dot dx. So this 2 will come outside. Here you are getting 1 by 3. Okay, sorry. 2 by 3 minus was there, no? 2 by 3 minus was there. Really sorry, guys. So 2 by 3 minus, what is happening here? X into x minus 1 whole square. This 1 minus x I am putting as x minus 1. X minus 1 whole square divided by 2 dot dx. Limit of x is going from 0 to 1. Okay. Two by 3 minus 0 to 1, x square plus 1 minus 2x would be there, no? So that will be multiplied with x. So x cube minus 2x square plus x divided by 2 dot dx. So 2 by 3 minus 1 by 2 will come outside. X to the power 4 by 4 minus 2x to the power 3 by 3 plus x square by 2, 0 to 1. 2 by 3 minus 1 by 2. So 1 by 4 minus 2 by 3 plus 1 by 2. 3 by 4 minus 2 by 3. 9 minus 8, 1 by 12. This is coming out to be 1 by 24 actually. So 2 by 3 minus 1 by 24. So 3 by 4 minus 2 by 3. 12, 9, 8. Yeah, 1 by 12, so 1 by 24. 15 by 24. 5 by 8. This is the answer we are getting. Okay. 5 by 8 is the answer we get. Okay, I hope there is no calculation error. So 5 by 8 is the answer you get. So are you able to understand? What we did, we just studied about the surface integration. This is known as surface integration, not line integral. This is known as surface integration. Okay. Here volume integral also you will study. Line integral, volume integral and surface integration also you will study. But in our analysis, only surface integration will be used. Line integration you already know, right? So surface integration in this kind of thing, it will be used. So in this second question, what was the important point? That first was choosing the strip. I got to know that choosing the strip is difficult here. So I already know the surface integration of the previous thing. I already know the surface integration of the previous thing, right? Of this particular region. So what I can do is that from this particular region, I can subtract this region. So I will get my answer. What answer I am getting? I am getting the answer as 5 by 8. That's it. Now we need to study about two-dimensional random variable, and that we will study in the next video. Okay. So in the next video, we will start two-dimensional random variable. So this was purely based on mathematics. Next video will be based on two-dimensional random variable. Okay then? Yeah. Thank you very much.